In solving right triangles, we just need to complete the measurements of the entire triangle in terms of 3 sides and 3 angles. For the sides, we can always use a Pythagorean theorem when necessary. As for the angles, we can anchor on the triangle angle sum theorem, which will help us solve the measurements of the unknown measurements of the angles pertaining on the total, which is 180 degrees. For this given triangle here, however, we cannot use yet the triangle angle sum theorem, for we only know the value of this angle here, which is 90 degrees. We don't know the measurement of angle theta nor measurement of angle alpha yet. So we can start by solving for the sides, because here we only have one unknown side measurement, and that's your hypotenuse. Take note, with this given measurements of legs, we can use here the Pythagorean theorem. And for this, we can write this equation that the square of the measurement of the hypotenuse is equal to the sum of the squares of the measurements of the legs. So we will have this notation. So x squared is equal to the sum of 100 and 196. So x squared now is equal to 296. And then we take the root of both sides to get the value of x. It's plus minus square root of 296, which will give us a result of x is equal to plus minus 2 times square root of 74. However, since x is a measurement of side, we will only accept the positive value of x is equal to 2, the positive 2 and the square root of 74. Or you place here the units, because we don't have exact units. Or you could also write an approximate value for x, which is 17.20 units. This is approximation because it's a radical expression and we don't know its exact value. Hence, we write this symbol. Now, any of these two is acceptable depending on the allowed instruction. Now, this completes the measurement of the sides. Now, we are going to solve for the measurement of the angles. Again, we cannot use yet the triangle angle sum theorem here, but we can use the concept of trigonometric function when we relate with the two given side measurements. Let's try to solve first angle theta. And with reference to angle theta, 10 here is our opposite side. 14 is your adjacent side. And of course, x is your hypotenuse. With reference to angle theta, we could write here or choose a trigonometric function which will use opposite and adjacent, and that's tangent theta is equal to the ratio of the opposite side, which is 10, over your adjacent, which is 14. But we are not solving tangent theta, we are solving for the value of angle theta. In this case, let us have an extension here. We are going to use the inverse trigonometric function of tangent, and that is tangent inverse or inverse tangent of the ratio 10 over 14. Approximate 35.54 rounded off into 2 decimal places degrees. So this is the approximated value for angle theta. Like this one. So with this, we can now solve for the measurement of angle alpha using the concept of the triangle angle sum theorem, which tells us that if we are going to add the measurements of the interior angles of this triangle, it will add up to 180 degrees. So we simply subtract the already given 90 angle here and the computed value for theta, which is 35.54 degrees. And since 35.54 is an approximated value for angle theta, we also use here approximated value for alpha, which is approximately equal to 180 degrees minus 90 degrees minus 35.54 degrees, and that's again approximately equal to 54.46. We use the unit of degree for angle. Degree of measurement for angle is degrees. So these are the three unknown measurements. We started with the value of x here, hypotenuse, and we used tangent, the relationship of the given sides, the proper identification of which function and its inverse function will be used is based on the given. Of course, you could always use the measurement of the hypotenuse and use another trigonometric function, but since value of hypotenuse is just an approximation, we can refer to what is already given. That's opposite, adjacent, hence tangent. And then you use that value to solve for the approximated value of the remaining angle. These are the unknown measurements for this triangle.